Okay, good afternoon, everyone, or I guess good morning in your case. Um, I'm here in Colorado. We're going to be talking about receiver testing and things like that. So you guys can see the screen, I assume. So we're talking about performance numbers on my website, but there's some confusion at times. So we're going to talk about interpreting those numbers. So are we good? So I have a picture of you in the room there. So just how many people have been to my website? Just raise your hand. Okay, very good. Well, this is the top 8 radios just to show you what the website looks like if you haven't ever been there. Unfortunately, there's assumptions made about what this data means, and I found this out in spades listening to a podcast. So why did I start testing radios in 1976? Well, K8RRH, George and I, we were both living in Cincinnati. Well, he was living in Cincinnati. I was in Colorado then, but we worked the 160 meter CW contest with our Drakes, and the reviews were good, but the receiver didn't perform well in a pileup. So the radio is what it is, and if the lab testing says it's good and a pileup messes it up, then the testing's no good. So just so you might know, a CW signal at about minus 60 dB, including the key clicks, is about a kilohertz wide. A sideband signal, including the splatter, is about 10 kilohertz wide. So often on sideband, reception limit for a station that's a weak one and there's a strong one nearby is the splatter of the other guy. So we need a test that approximates an on-the-air contest, de-expedition, or whatever. Signals aren't spread out at a de-expedition all over the band. They're up 2 or 3 kilohertz, 1 or 2 kilohertz on CW, and up maybe 5 or 10 on sideband. So let's look at how rigs were tested before 1975 and what are the limits of new performance definitions in 1975. So what data did we have 51 years ago? Well, the specs were typically quite limited. We had sensitivity in microvolts, and I still publish in microvolts so you can compare over the last 50 years. Selectivity, and particularly once the Collins filter came around, shape factor, and then something called cross modulation that was just really an AM figure of merit. I haven't heard that term in years. But all this changed in 1975 due to articles published in QST and Ham Radio Magazine. So what was new 50 years ago? Noise floor in dBm in a 500 hertz CW bandwidth. And then the two-tone dynamic range was also measured on CW. Unfortunately, back then, the dynamic range was only measured at 20 kilohertz, meaning there was a signal 20 kilohertz away and 40 kilohertz away, and we were looking for the distortion product. But that's not the way pileups work, spread out like that. And that was already obsolete for the R4C as far as how it performed with this 20 kilohertz test. And then along came the upconversion radios that got rid of pre-selectors and gave us general coverage and all that. So the TR7 from Drake may have been the first upconversion radio, and that started a trend that lasted for over 20 years. So what was the dynamic range problem? The topology of the superhet radios changed. We had a first IF that was probably 15 kilohertz wide, above 10 meters, or above 6 meters. So this filter at the front end had a lot of signals in a 15 kilohertz bandwidth, and then lots of gain, and then a crystal filter at a second IF between 4 and 11 megahertz. The trouble was in a CW contest, because those signals are discrete and not spread out very much, these radios could overload. The 20 kilohertz test data didn't show the problem. So 1 year after these publications in the magazines in 1975, I introduced what we'll call the 2 kilohertz dynamic range test. In other words, the test signals to approximate a DX pileup or a contest Well, with the 20 kilohertz test, these radios back then would measure 80 to 90, and that sounds good. Certainly 90 is very adequate. But if you squeeze those test signals closer so they got through that roofing filter, that 15 kilohertz roofing filter, the dynamic range cratered to 65 to 75. So the typical back then was 70 as opposed to 90, just because the signals are closer together. So where are we today? Well, both QST and my reports on the web and with my long form reports that are in PDF form, we publish both 20 kilohertz data and 2 kilohertz data. But my website has 14 columns of data on more than 150 radios going back 50 years. But all these radios are only sorted or ranked by the 2 kilohertz column. But most hams just look at just the 2 kilohertz column data. The radio's position in the table is not an overall ranking, and that's really key. The other columns are not ranked top to bottom, so if you want to look up something like noise floor sensitivity or whatever, you need to look at those individual numbers. You can't sort a table with 14 columns, all of them at the same time. So I was listening to a podcast discussing the new FTX1. This case, it was the Field, the QRP radio, and comparing it to an ICOM 705, which is a cute little radio that I've certainly run in contests. Unfortunately, I figured out the reviewer assumed that because the Yaesu in this case was 3 dB better on close-in dynamic range than the ICOM, that it was also more sensitive, which was completely backwards. If you look down there below, the sensitivity, the smaller the number, the more sensitive it is. So that was something I had, okay, I've got to deal with this confusion that this is an overall ranking. It's not. It's a ranking by close-in dynamic range. And so if you want to know something else, you got to compare. If you want to compare noise floor values of those two, you had to really look at those specifically. So what else do we not want to do? Don't choose a radio today by one number. Now, you can say you go back there approaching 50 years ago when the radios with the up conversion dynamic range of about 70, well, if you were going to compare it to a radio that's about 80 or 90, then maybe you could say we're going to use one number, at least as the major thing. But now, radios, there's over 20 transceivers that have a close-in dynamic range more than 90 dB, which is completely fine. And also, it isn't the noise floor or the sensitivity that's probably going to make your decision. They're all fine, but they're so different. If we're going to compare radios, you say, I'm going to buy a new radio. And they're so different in the user interface, the knobs, the buttons, the display, small display, big display, external display. Does it run with your computer? Or do you just take it out of the box and plug it in? The ergonomics, the way that it works for you, is all over the map. And the menus that certainly are necessary to set up things like sideband EQ, maybe your bandwidths that you want on CW and sideband. Do you have to get into the menus when you're in the middle of a contest or middle of a de-expedition or working a de-expedition? So it's really critical, are most of the things right there at your fingertips. So if you've got a new radio in mind or a couple, consider your local Hamfest or your local ham club and see what your members are using and try out one if you can. So go to your friend's house and try out a new radio that you're considering. Or if you have a local ham store, make use of it, because this is all subjective on what works for you. So the basic performance of all original equipment manufacturers, there's the 6 big ones. You can contest with dozens of rigs today that are going to work just fine as far as the basic performance. Some time ago, we wanted the magic 100 dB radio, and that's now common. So you've got choices by brand, cost, and size. I operated multiple CW contests the fourth quarter of 2022 with a $1,000 radio and a $1,500 radio, which I'll show you in a moment. The interface and the ergonomics was all over the map again, so I kind of had to get used to them. So there's operating position 1 when it was set up to look at those two Yaesu radios, the FTDX10. So that's the 10, and also the FT710, which was Yaesu's first direct sampling radio. Like I say, entire operating, DXing, contesting, rag chewing was all just done with these two radios over 3 months. So here's the top 26 transceivers off my website, but it's not counting down 1 through 26 because there's duplicates there. There's the K3, the K3S. There's even a K3S compared to a Flex. And then all the direct sampling radios, some of them have a second sample because the ADC chip, the analog to digital converter chip, they're not identical. Now, they're not drastically different, but there's enough scatter in the data on a direct sampling radio that there's 2 listings often for many of the direct sampling radios. And the variation might be 5 dB or something. But look right there in the middle of the pack, 100 dB radios. You couldn't buy that 20 years ago. So the range here of just an arbitrary top 26 was 87 clear up to 110. Do we need 110? Not really, but it's great. So how are you going to select a new radio that you say, I want to get something that's more modern than what's in my shack? Well, I'd say pick one of those top 26. You can't go wrong. If you've been say a Yaesu operator forever and you want to stay with that, fine. Every one of those top 6 OEMs has a good product. Pick a price that fits your budget. Speaking of price, right now, current product from the 6 OEMs is from $1,000 to almost $10,000. So it's all over the map as far as cost. And also size. If you're going to be on a summit on the air or a parks on the air, you probably don't want a 35 or 50 pound radio. So it depends what you're going to do. So let's look at some of the lab numbers and see what they mean. So from my website, left to right, the noise floor is rarely an issue due to urban noise. Band noise is, even in a quiet location, is likely higher than receiver noise on 15 meters. But then if you're at a SOTA site or a POTA site and you've just got a limited antenna, or maybe you've got a receive antenna, it's a beverage or a loop or something, then you may be more concerned about the noise floor of the radio. But let me stress, the most important thing you can do to make your signal better is to install the best antenna possible within the limits. Maybe you've got an HOA, but antenna is really important. One of the columns there is the AGC threshold. Now, on the lower bands, band noise is always going to be higher than the AGC threshold. So consider using your attenuator or your RF, reducing the RF gain to raise the AGC threshold 3 to 6 dB above band noise. Now, why do you want to do that? And if you're tuning the band, we call it search and pounce if it's a contest, or you're tuning looking for DX, you don't really want band noise to be brought up by the AGC to be as loud as every signal. So if you can add attenuation or back off the RF gain, then as you're tuning between stations, you're not inundated with just band noise. It really does reduce operator fatigue. Give it a try. Blocking, that's a number that gets measured in QST and in my website. Everything can block eventually. It could be a signal out of band. And the direct sampling radios have a ADC, analog to digital converter chip, different dynamic range, just like a superhet radio. But most of the time, blocking or ADC overload is not an issue. It's usually a line of sight station that's like, 60/9. What's a good value? Well, for a direct sampling radio, the average value is 125. A K3S, for instance, is like 150, but really 125 is usually adequate. And if you don't have anyone nearby, it's not an issue at all. The closest ham to me is 13 miles away. Sideband sensitivity. That's a 10 dB signal plus noise to noise ratio. Like with noise floor, today's man-made noise, particularly in an urban environment, usually sensitivity is not an issue. But there again, if you're working sideband on POTA, you may be concerned about it. So what's a good number? Well, 0.15 microvolts with the preamp for a modern radio or a legacy radio like a Collins or a Drake. 0.15 microvolts for 10 dB signal plus noise ratio has been a good value for 50 years. So there's no magic out there. That's a number that makes sense. Reciprocal mixing dynamic range, which measures the local oscillator or the clock noise quality. That's probably the least understood of the many parameters on my website and in the reviews in QSD. Now, if we go back to your Collins and your Drake, this wasn't an issue. We had a permeability to an oscillator or a VFO and band crystals. But then synthesized radios came along with the TR7 and other ones. And the early ones had really pretty terrible synthesizers. So we were lucky that any new radio introduced in the last 5 to 10 years, it's not an issue. They really finally learned how to make synthesizers, which was a major improvement. And the direct sampling radios just needed a clean clock, the clock oscillator. If you do want to compare current RMDR numbers that are published in QST to my LO noise column, just subtract 27 dB. So this example, if the noise was minus 137 in that column, you change the sign, subtract 27 dB, and you get 110. So 110 is great. Front-end selectivity. Most rigs have either a half octave or ham band only LC filters. A few have a tracking pre-selector, the FTDX 101D, the MP, the ICOM 7610, and the 7760. Now, to give you an idea, the bandwidth of these tracking LC filters, they are not really sharp. The Yaesu's on 40 meters at minus 10 dB. In other words, the LC filter is going to knock down something you don't want by 10 dB. It's about 250 kilohertz wide. And for the ICOM, it's 500 kilohertz wide. Some people will say if you take the 101D and off-tune the tracking pre-selector, it's going to get rid of QRM 5 kilohertz away. Well, that's just nonsense. If we've got a filter 250 kilohertz wide or wider, it's not going to have an effect 5 or 10 kilohertz away. So the main improvement of the tracking pre-selector is reducing out-of-band commercial signals, like on 40 meters above 7.2 megahertz at night. Maybe you're working the low end on CW, so that'd be helpful. And of course, if you're on field day, you probably need external LC filters if you've got multiple stations on the air at the same time. So finally, we're back to dynamic range. So we've got more than 20 transceivers with a 2 kilohertz dynamic range over 90 dB. So most hams just don't have an overload problem. However, some radios have a roofing filter. They have a superhet front end, like the FTDX10, but then they're digital after that. So the roofing filter has an advantage for signals that are further away of about 20 dB. So if you've got a ham line of sight that's 60 or 70 over 9, and you're both going to be on the same band at the same time, then you may want to consider the radios with the roofing filter. And certainly on a field day, if you've got a CW station, a digital station FT8, and a sideband station all in the same band, you probably want to pick a radio with the roofing filter. In a multi contest station, we've got the malt station that's tuning around to pick up malts, and he might get pretty close to the run station. So again, the roofing filter is helpful. This has got a lot of numbers here. I'm going to synopsize it. I was wondering, well, what would it take on 10 meters? For instance, I hope you guys worked CQ Worldwide on this past weekend. It was phenomenal. The bands were great. Sunspots fell into place. So at my QTH on 10 meters, with no preamp, my band noise is about equal to my receiver noise measurement, about minus 130 dBm. So how strong would interfering signals that are off frequency going to have to be to cause an intermod product, a distortion product on top of the weak guy I'm trying to work? Well, it would be about S9 plus 45 dB. Now I worked on the air last weekend on CQ Worldwide. I just did 10 meters. I was on the air for 18 hours and had over 600 contacts at 107 countries. I never saw a signal S9 plus 45. So it's just not really a problem with a 100 dB radio or 99 dB radio. Now, WRTC in Europe on 40 meters at night, the 7610 being a radio without a roofing filter, I know that some of the operators use 9 dB of attenuation. Otherwise, the little overload indicator would be on. Well, band noise at night on 40 meters is minus 100 dBm. And the noise floor of the 7610 with no preamp is minus 132. So that's way too sensitive. I probably would have picked 15 dB of attenuation or 12 for use there on 40 meters in Europe at night to reduce the potential overload from the signals, the AM broadcast signals above 7.2 or maybe even the 49 meter band, which is a commercial broadcast band. So again, if we've got a 100 dB radio, we're probably never going to run into a case that we're really overloading the radio to cause intermod. So what is the mistake made most often? Because every radio is sensitive enough for 10 meters, let alone 6 meters, which is now standard, they're too sensitive on 160, 80, and 40. So if you're using a preamp on the lower bands, that's likely totally the wrong decision. I know it's sort of counterintuitive to say, well, why would I want to attenuate signals? But if your band noise is reading S7, you're certainly not needing more sensitivity. So when I'm on 40 meters, 80, 160, I'll probably start with 12 dB of attenuation at night. And one time on a 160 meter CW contest, I was comparing two rigs and I ran 18 dB of attenuation. So that was, it reduced the noise fatigue drastically. So what's changed? So up conversion radios were replaced with what we call down conversion. That just means a low IF, around 9 megahertz, 8 megahertz, something like that. Well, once the Orion 1 from Tentec came out, and then the K3 came out in either late 2007 or early 2008, well, the up conversion radios with the wide 15 kilohertz first IF went obsolete. So both the Orion 1 and the Orion 2 and the K3 have a low frequency first IF. That's what we call down conversion. But of course, if you're on 160, it's not down, but that's just the term. Today, we have 3 Yaesu models and 2 Kenwoods that are down conversion. So the up conversion radios that had about a typical 70 dB, 2 kilohertz up conversion dynamic range couldn't compete with like the 105 dB dynamic range of the K3S or the expensive ICOM 7851, which was also a 105 dB radio, but it had a $300 roofing filter in it. By the way, if you've looked at the ICOM 7760, that is not an up conversion radio with a roofing filter. It's a direct sampling radio like 7610. Matter of fact, the receiver is basically a 7610. So what about direct sampling rigs? Currently, we have dynamic ranges between about 97 and 107. with the built-in linearization that we call dither. Don't worry about that in great technical terms, but it linearizes that ADC chip because they're not perfect. But then look at that ICOM 705 that was in that review in the podcast that I was listening to. Well, its dynamic range is 88, and I've used it twice on 160 CW, ARRL, and ARRL 10 meters. So it worked very well. So one thing that is different about the direct sampling radios is the test data at 20 kilohertz is usually identical to 2 kilohertz, unlike the ones with the roofing filters that were 15 kilohertz wide, where the 20 kilohertz data was big number and the 2 kilohertz data was maybe 20 dB worse. So that's the difference. So what rig should you own? Well, I'm often asked why I didn't own the top Yaesu rig on my website, which is be the 101D. I did own the FTDX10, I still have that, the FT710, which is their direct sampling radio. So I did use them for a while. They worked well, but they were very different in the user interface, the ergonomics, the band scope, and the waterfall. I want to have almost a minute of data in the waterfall as I'm working the contest so I can see which signal I'm going to tune in next. So that's just preference of you, the user. So this is 100% subjective. Now, the fact that I'm using 7610s is no bearing on what works for you. You really want to sit down in front of a new radio, if you can, and see if it looks like the interface between you and the radio makes sense for you. So in 2007, my ex-well said, it's time to build my dream station. I had been operating in the Rocky Mountain foothills for 7 years with a lot of mountain blockage. Thank goodness I had a decent shot to Europe, but my shot to JA was about a 45-degree angle, so I didn't work any JAs. So I moved to the Colorado Plains, about 50 miles east of WWV, in 2007. Here's a picture of my station. Now, admittedly, you can say I went crazy. I've got 6 towers with 9 HF monoband Yagis. So this is what I'm doing when I'm testing those Yaesus, for instance, or whatever brand I'm testing on the air, in addition to the lab testing, to really what's it like in a contest. So every Yagi is monoband, and this is something that I learned from W3LPL, Frank Donovan. He said if you've got more than one tower and you've got tri-band beams, they can interact with each other. So I don't happen to have any trapped antennas, so they're all monoband, which admittedly everyone can't do that. But that reduces the interaction with multiple towers and multiple beams. Also, even though it wasn't originally planned, I've got 2 Yagis on 20, 2 on 15, and 2 on 10. So what I do during a contest like this past weekend on 10 meters, the 3-element Yagi was pointed to the Caribbean and South America at about 135 degrees for someone in Colorado. And then the 4 or 5-element Yagi, in the case of 10 meters, the 5-element, was followed the skip, from Europe to during the day to South America at times, but then JAs and VKs and all that later in the afternoon. So here's my normal operating position. At position 1, as you can see there, the radio is the 7610. You can also see the little VHF radio to the left, and the 6 rotor controllers and the alpha amp. Here's operating position number 2, where I was running the FT710, for instance. Again, similar setup. The extra monitor on the right is to control the Yagis with PST rotor. And here's a third operating position with the ACOM and also my 630 meter transverter. So to the left of the rig over there with a little LCD screen is when I work 630 meters with the rig on 160. So how do I change bands during a contest if I'm really going to be doing a 6-band effort, I just changed operating position. So during the daytime, the 3 would be set up for 20, 15, and 10, and at night, 40, 80, and 160. However, now at 78 years old, this past CQ Worldwide, I just had fun on 10 meters. It was unbelievable. It was the best conditions I'd seen in 18 years out here in the country. There was almost a megahertz of signals on 10 meters, from 28.3 to 29.27. Unbelievable signals, and it was open to the Middle East for hours at a time. It was just unreal. So, do you have any questions of my data? You can contact me by email, or we can have some Q&A here at the end. But it frustrates me that when a radio is sorted by dynamic range, that the user might assume that all those other numbers are also sorted, and they're not. So when you want to look at a column of data to compare rigs, for instance, say it was reciprocal mixing dynamic range, the LO noise, you've got to look at the columns and compare the data. One thing I say, this is a hobby. Enjoy using your radio. Whatever you own, it should be fun to operate, whether you're operating drag chewing 18 hours in a contest or struggling with a de-expedition that you took 2 hours to work the guy. It should be fun to use your radio. And if it's a struggle, well then try something else. So your club will have a PDF of this presentation. And my email is rob@nc0b.com. So you're certainly free to ask questions later. Now I'm going to stop sharing and let you guys see if you have any questions. I know they think they're going to pass around a microphone. Do we have our moderator there yet? I know I'm done a little bit early.
Yeah, give us just a second here.
Sure.
Okay, you ready for questions?
So how do the numbers like you're talking about with rigs, how do they apply to like the dedicated SDR receivers that some of us use?
Give me an example of what you're using.
Well, it's home built. It's just a wide spectrum SDR receiver. I can't think of the guy who did it. It's for the reverse beacon project. The guy there has a wide spectrum receiver that we use for beacons.
Right. Well, I assume in that case you're talking about a $100 to $300 little direct radio. Is that correct?
Well, no, it's as I say, it's home built. He designed the ADC, and then it uses a custom GPU type board to do the processing.
Right. Well, I'd say for the most part, the only thing that I've tended to use, or know a lot of people use something like that as the second receiver. When you're working a de-expedition, they're always split. So you want to listen to the either where everybody's calling or listen to the DX and use the main receiver, whichever is appropriate. So it's these inexpensive radios, or the ones that you built yourself, like you say, usually have limitations. Maybe it's the spurious, or it's the how clean is the local oscillator clock. So the ARRL tests a lot of these inexpensive radios, and so I would say they're stressed more on how to test it because there's more limitations on making measurements than with the mainstream radios that cost $1,000 to $10,000. So I say use what works for you. I would think that for the most part, you'd want to have your main radio listening to the DX and use your little sub radio to find out where to transmit next, so you can see both sides of the de-expedition.
Oh, looks like the hands are coming up here.
Mine is not a question, but a compliment. I, in the 1980s, bought a Japan Radio Corporation NRD 515 from Tom Harrington and shipped it off to you for the SE3 modification. I don't know, 10 or 20 years later, the receiver got zapped by lightning, so I bought a replacement NRD 515. And I continue to use your SE3 unit on a daily basis for hours and hours of program listening. I don't think you could find a better combination for quality audio. And the 515 has good specs, and I remember looking at your tables back then, but your Sherwood modification, the SE3, continues to do just yeoman's work every day, provide me with the most incredible listenable audio from shortwave broadcasters, and for 40 years of listening pleasure, I thank you, sir.
Well, thank you very much. In case you don't know what he's talking about, it was an accessory. It was relatively expensive, around $700, and it would take the IF out of the 515 in his case, and synchronous detection. So it eliminated selective fade distortion that if those of you who were on the air in the 50s and the 60s and even the 70s on AM, like with my Viking Ranger and my national receiver, selective fade distortion drove you nuts. And this totally eliminated that, and it did not lose lock. It also, I called it a hi-fi detector because if you were listening to a broadcast station, whether it was a shortwave or just the AM band, it had fidelity out to 5 or 10 kHz depending on the station you're listening to. So it was sold for over 30 years. So it was kind of fun to sell something that lasted that long. There wasn't someone who was going to ask a question over on the left there.
Hey Rob, this is Philip Nodlinger, KA4KOE, and it's not really a question, but maybe your opinion on this. You know, people see these receiver figures and they say, well, that radio is junk, or it's no good, it's no good. But I've always looked at it from, is it good enough to do what I want to do? I've used an FT897 Delta for almost 20 years. I've worked a lot of contacts on it. It's got its shortcomings. It's always been, this is an up conversion, I believe. And I've always been of the opinion that the radio you have to do what you want to do is the best radio there is. And that's the radio that I use for POTA a lot of times. It's not the best radio by a long shot. The technology is at least 20 years out of date. But I think people might get really wrapped up in the numbers. I think some of these splitting hairs is primarily for contesters' benefit. What do you think about the best radio to use as the radio you have available? And this is not from my way to approach things. I love the little radio. It takes a licking and keeps on ticking. Heavy duty. It's what I like to use. Back to you, sir. Thank you.
Okay, well, I totally agree with you. We can get way too wrapped up in the numbers. Like I say, all we had for 20 or 25 years were the 70 dB radios. And for sideband, it really was fine because the sideband splatter, the intermod, that's now being dealt with by 3 of our OEMs with something called pre-distortion to reduce that splatter. On sideband, the 70 dB radio did fine because the guy that's 5 kHz away with his splatter sidebands were on top of what you were trying to listen to. And you're right, whatever is working for you. I mean, I'm out in the middle of nowhere with the closest ham 13 miles away. I don't see signals that are 60/9. So what's important is, do you enjoy using your radio? And in your case, if you're taking it out in the field, you don't want a 50-pound radio. So it should be fun to operate what you've got. As long as it does what you need, then that's the perfect radio for you. So I totally agree. We don't need to say, well, I've got to go spend $9,000 on a radio because that's supposedly the best radio. So that's a good advice you just gave. Over here on the right.
Rob, a more pragmatic question. What are you using for logging and for station control with your station?
Okay, well, I use N1MM. A lot of people use that. I know K3LR uses something else, but I'm very happy with N1MM. The station control, I mean, there's not a lot I have to control except the other two operating positions. I've got to turn the beam because the 3-element beams pointed to the Caribbean and South America. The 4 and 5 element Geigers are going to follow the skip. So really all I need, depending on which seat I'm in, is rotor control and N1MM. And so that's really all I do. Thank you for the invitation. Enjoy the rest of the weekend.
Thank you for joining us from Colorado.
My pleasure.